So let's look at simplifying exponential expressions. I guess there should be an extra part of that title. Okay, so we have two equivalent expressions, right? We have a quarter to the power of x squared plus 2 is equal to 1/8 to the power of 2 minus x. So usually the easiest way to work with any of these is if we change everything to the same base. Now, if we know our 4 or a 4 base, as soon as we go squared, right, so we have 4 to the power of 1 gives us 4, 4 squared gives us 16, so that doesn't really work for 8, so we're not going to be able to work in that base 4. So we're going to have to convert both of them. Do you know what a base that might work for both of these?
2.
2, that's right. So if we know our base 2 rules, so we go, obviously 2 to the power of 1 is 2, 2 to the 2 is 4, which is great, which means we can now replace 4 with 2 to the power of 2, and 2 to the power of 3 is 8, which also works out great. We can cover the exact same idea. We'll replace 8 with 2 to the power of 3, and we'll replace 4 with 2 to the power of 2. That way we're working with the exact same base. So we now have 1 over 2 to the power of 2 to the power of x squared plus 2 is equal to 1 over 2 to the power of 3, 2 minus x. Now there's a couple ways we can kind of go about this. We're working with fractions, and if you're strong with fractions, then that's great. We can continue working with it. But maybe you would prefer if our bases were actually the tops of the fraction and everything was divided by 1. We can do that exponentially by essentially creating a negative in the exponent. So if we make the exponent negative, it inverts whatever there was there. So instead of writing this as 2 to the power of 2, and technically the reason we can do this, this is technically 1 to the power of 1. It doesn't, we don't need to write it in, but it is technically there. We can flip this. We can invert everything here. So this becomes 2 to the power of negative 2, and it's technically over 1, right? We've inverted the base itself, and you could have said it's 1 to the power of negative 1, but again, doesn't do anything. The 1 doesn't change. But we don't need to write any of that in. We don't need to divide by 1, so we're just going to simplify by writing it this way in the brackets. Okay. It's still going to be the power of x squared plus 2. And then we're going to do the same idea on the right side. We'll have 2 to the power of negative 3, and then 2 negative x. Okay? This is a power of a power. So if you know that rule, it's usually written like this. If you have, say, x to the power of a to the power of b, it can be simplified by writing x, so x is our base, and writing a times b. You're familiar with that rule? Okay, great. So what's happening here is we're now going to do negative 2 times all of the exponent on the outside. And same idea here, negative 3 times whatever exponent was on the outside. So still have the base 2. But the tricky part here is we're actually going to start using what they refer to as distributive property. So we have negative 2, and it's times everything, not just our x squared. Okay? So we'll have to eventually distribute that. And we'll do the same thing on the right. We have 2, and we have negative 3 needs to be distributed or times both of the values in the exponent on the outside. Okay? So this is great. We can distribute, but we can also make this a little easier for yourself to look at. They're both base 2, so sometimes they'll tell you can cancel out. Really what you're doing is taking the log of both sides. So say we're taking log, oops, that sometimes happens. You could say, and I'll write in, you guys went over logs?
Yeah, we did.
Okay, great. So if I was to take the log base 10 of both sides, what actually ends up happening, because they don't usually write this in, is the exponent jumps to the front in both of those cases. Okay, so I'm going to write this out. And normally you can, like I said, you can skip this step by just canceling angle to 2, but I just want to show you what they're actually doing. Is we have negative 2 x squared plus 2, and then we have log base 10 of 2 is equal to negative 3 times 2 minus x, and then log base 10 again of 2. So the idea here is you can divide both sides by log base 10 2, and again, that cancels out. So that's really how you're eliminating the exponents on the bottom. Okay. So now we're left with negative 2 x squared plus 2 is equal to negative 3 2 minus x. So we use distributive property. The value has to go into both of the brackets. Sometimes they call it rainbow. I'm not sure what they refer to it in your school.
We call it foiling.
Foiling, yeah, okay. And usually foiling is when they call it a binomial, when there's two terms in each.
Sorry.
But you're right, it's distributive property.
Sorry, the wrong name for that.
That's all right. So negative 2 times our x squared gives us negative 2x squared, and the negative times positive is going to give us negative 4. Okay. And then same idea here, negative 3 times 2 gives us negative 6. negative 3 times x gives us positive 3x. Okay. Let's move everything to one side, and we're probably going to end up with looks like a quadratic function, okay, or a quadratic expression, I should say. So when we move everything over, we'll have negative 2x squared. When I bring the positive 3x over, it's going to become negative 3x. We'll still have negative 4. And when we bring our 6 over, or negative 6 over, it will become positive 6. Now that we've done that, there's nothing left on the right side. It's essentially equal to 0. We can simplify those two terms. So negative 2x squared minus 3x plus 2 is now equal to 0. So now we have a quadratic, and we need to factor or use the quadratic formula depending on what your teacher prefers you guys to use. There's lots of ways to factor. What we're going to use is something that always works. Okay, so we get x is equal to negative b plus or minus the square root. Oh, I guess that's going to be in the blue. All right, the square root of b squared minus 4ac over 2a. Now, in order to do this, you kind of need to know that this is a, this is b, and this is c. And are you okay with those ideas? Mm-hmm. Yeah? Okay, great. So now it's really just plug it in and carry out things using BEDMAS. So I'll try to go through it somewhat quickly because I think it will something you already know. So because this is negative b and that's negative 3, it ends up being negative 3. Okay, so that's going to be a positive in the end. Mm-hmm. Divided by our b squared, so it's going to be negative 3 squared. So I'm just going to write that in as 9. Are you okay?
Yeah, that's fine.
All right. 4 times negative 2 times 2. And then 2a, well, that's 2 times a. So negative 2 times 2 will give us negative 4 on the bottom. Okay. Now we just got to work out inside those brackets. This is 3 plus or minus. Okay. And let's see what we can get. Okay. I'm going to try to do this a little quicker here. Negative 2, think of this as a negative 4. So negative 2 times negative 4 is positive 8, times 2 is 16. Okay. And we ended up with 9 subtract, no, sorry, it's positive 16. So 9 plus 16. So it's going to be 25 underneath here. Okay? Mm-hmm. That was okay? Yeah. Okay, so we get 25, which is a very straightforward number to root for us, all divided by negative 4. So this is where it kind of splits. X is equal to 3 plus, and that's going to be 5 over negative 4. And x is also equal to, so because it's plus or minus, right? So we have the plus value, and x is also equal to 3 minus the value of 5 over negative 4. So we end up with our two answers. Okay, this becomes 8 divided by negative 4 is negative 2. Okay, and this becomes negative 2 over negative 4, which is positive 1/2. Now, that gives us what our x values are. But let's say they really wanted this to be in a factored form. You can write this in factored form by literally just putting two sets of brackets, okay, and x with no coefficient. So that's just the number 1 in front. We don't need it. And then we just fill in the other two slots with the negative 2. Oh, sorry, the opposite. Very good. Positive and negative 1/2. And that is technically the factored form. Now, because we did the quadratic formula, we didn't have to do the next step of solving x. We've actually already solved for it in these two spots. So in our question, what were the values of x? It's quite a long one. We got negative 2 and positive 1/2 as our two answers.